you need to realize is that's going to be a fixed unit of energy for this house for at least the next 25 years. So as energy costs are rising, they'll know for exactly how many kilowatt hours this thing produces each year. They know the cost of it. So that's really the thing we need to pull away from this little demonstration. But just to give you a rundown of the system, we went with the microinverter system. So you're not going to see an inverter mounted on the back wall. They're all mounted up underneath each panel. And we've got 7 Trina 235 watt panels with a DC capacity watt of 1.645 kilowatts. And underneath each one of those, like I said, are 7 in-phase microinverters. They actually take the DC current from the panels and convert it right there underneath. So coming off the roof is AC power, where in typical solar systems it would be DC power going down to an inverter, but it's then turned into alternating current. But really, that's...
Is there an advantage to doing that on the roof in the heat, 140 degrees plus, versus doing that conversion inside the house?
There's not too much of a advantage. There is a good amount of airflow underneath those right now, so I'm sure down here at some points we'll see 140 degrees, but hopefully it'll stay cool. And from a monitoring standpoint, we like to use microinverters on a smaller scale system. You can look at each individual panel online, and we feel that it's nice to go ahead and just transfer up there on the roof and just pull AC wires all the way through the building.
Makes the connection easier.
Make the connection a little bit easier.
The disconnects from a power company standpoint are a little bit simpler and all that too. But it's 120 volts on each leg, and right now, like you said, it's 1.6 some odd kW equivalent DC capacity. Now we got almost a perfect day at the angle the panels are at and the angle of the sun, and we're getting about maximum output. Of course, in the summer when we get the sun directly overhead, we'll get a little bit more out of it, but we're getting about 615 watts on each leg, or about 1.25 to about 1.25 kW. When I came up today with really nothing on before the blower door was on, the house had a consumption of about 900 watts, and we were producing 1200 watts, so we were actually putting power back on the grid. So it's pretty neat. It's pretty straightforward. We have the energy monitoring system measures the output of the photovoltaics plus the consumption of the HVAC system, ventilation system, the plug loads in each room, the washer, the dryer, the dishwasher, the microwave, the stove, and the refrigerator. So we're going to have a lot of data to study on this little house. We're going to compare it then to the total consumption of a conventionally built house next door, and hopefully generate some good data on, maybe it's not completely practical to do this on every house that's built now, but to as a pilot project, see where we might be headed and how we can get to net zero for every new building by 2030 or so. Just pretty neat.
The options that SC&G has. I know you and Kate had some email.
Okay, on a system like this, there are basically 2 ways to meter this house. One is net metering, where you buy power from the power company and you just put the power back into the system, and it either flows into your house and gets consumed, or it flows back out the grid. Using that scenario, you either offset your utility bill at the exact cost you're paying for power, or you get paid what you paid for power at the same price. There is another one where we could have had 2 meters on the building called buy all, sell all. For a system of this size, it really didn't make sense, because you buy power at one rate from SC&G, and then you sell all the power back to SC&G at another rate. For example, we buy power at about 11 cents a kilowatt hour. We would have gotten about 5 or 6 kWh back from the power company for what we made, which is a loss. And then had you been able to participate in something like the PACE system where you get another 15, 16 cents a kW, it might have made sense. But the PACE system is not taking any more members at this point, so it wasn't available to us, so it made much more sense to offset the power bill at the rate we're paying. And right now, based on what we're looking at, probably this is going to offset the utility bills in the house by about $400 a year, and we don't really expect the utility bills to be much more than a total of maybe 6 or so. It's going to cut the utility bills in the house down to, we're hoping, $25 a month or less.
I think we estimated about close to 1,900 kilowatt hours a year.
Yeah.
Yeah, and it's just a good feeling to know that you're actually using the power you're producing on site. And,
right.
Well, when you do sell off, it is getting used by somebody else, but it's nice just for this house to be using this power.
The other thing with that buy all sell all on this way too, you don't get into any tax situation. If you got a bigger system of buy all sell all, when you're selling, you're actually become a power company. You have to pay income tax on the money you get for your power. If you net out at the end of the year $35, it can be aggravating.
That 15
you've
cents.
had to pay income tax on that. So
that 15 cents turns into just a few after.
Yeah, that's right.
What's the maintenance component on that? Does normal accumulation of dirt lessen the efficiency? How often does it need to be cleaned?
There are soiling issues, but there's really not that much maintenance. Rain's going to take care of any big pollen days we have or dust debris that gets up there. We on our flat roofs we have a system where we will actually put a pipe boot up and we can run a hose up there and sit there and spray them off. So if in the springtime we go 2 months without a rain and you look up there and they look a little yellow, you might want to just spray them off. But other than that, there's really no maintenance involved.
We get enough rain. I mean, if you're in New Mexico or somewhere where you got 363 days a year where there's no rain, it might take some washing off every now and then. But even panels that's been installed out there for 30 years still produce 90% of it.
One other key thing about the in-phase microinverters, the monitoring will allow you to look at each panel individually. So the homeowner will be able to look online, and if for some reason there's a lot of dust in one panel, you'll see that the other panels are up, around 190 watts, and then that one's at 80. Like, okay, well, we need to address that issue.
This looks like it's hooked on the standing seams of the roof. Is that how it's attached to it? What division is so the thing that gets sucked off?
Yep.
And
yes, sir. I got an engineered letter, an engineer down here, and those are what's called an S5 clamp. So it literally just has a set screw that pinches the seam. It does not penetrate the seam, it just pinches the whole on.
so it's really relying on it's held on to the roof, because the roof is held on well.
Right. That's taken into account by our installation crew. They look to see where the roof's attached to where they put those clamps on, and this is another aspect that we work with you guys on.
What kind of miles an hour can that sustain?
Whatever the building code was down here, I think it's 120 or 130.
130.
Well, 130. So that's what it's engineered for. But it was when we were working with them on choosing the roof, we said, hey, you might want to look at a standing seam roof. You might already look at that, but we won't have to make any penetrations except for our one conduit. If you go with the standing seam, like if you used an asphalt shingle roof, they would obviously be flashed properly, but you still have holes in your roof. And that scares people. And that's where it's nice to have a roofing company as our parent.
This is your recommendation for water tank.
Right. Yes, sir.
Yeah, it's essentially got a little 1-inch conduit with a weather head on it. Not much different than a plumbing vent.
If I wanted to do this install in my house, price range or something?
That's the good thing about solar panels right now. The prices are coming down. I'm sure y'all seen everything going on in the news. Manufacturing prices are lowering. So I would say a typical residential install this size is around turnkey is probably around $6 a watt install. Obviously the the larger size you get, you can take advantage of economies of scale. But that's pretty. No, ma'am. That's before the tax credits. Talk to your accountant about what you're eligible for. But you get 30% from the federal government. South Carolina, 25%. Cap at $3,500 a year. There's not a cap on the federal. And that is big in the first year.
Alec, you want to talk a little bit about what that is, Boeing?
Oh yeah, we installed a system over there. It was about 2.6 megawatts. It was a good project to do for the state of South Carolina. Really got a lot of good news, and it kind of came out when all the labor talks started coming out, so it kind of came out at that time. But yeah, it's we use a thin film technology over there. The panels that adhere directly to the roof, mainly because of the wind loading in that area and how high the building was. Yep, we're very excited about that project. It's I think about 18,000 panels.
When does it go online, or is it already online?
It's already online.
How much of that power will that generate?
We're not
percentage-wise?
We're not sure. We were just hired on to install the system and all the estimated power, and that's all.
When you say adhere to the roof, so the roof needs to be redone in 20 years. I mean, what are we talking about here? You throw the system out?
Well, the system's warranted to produce power for 25 years. There's a sacrificial slip sheet that is in between the panels, so it's essentially just another piece of membrane roof. And so if for any reason they want to throw it out, they can cut away that sacrificial sheet, and the original roof has not been.
If they wanted to, if they needed to re-roof,
if they need to re-roof within 20 years, yes, you would have to. And it's nice because you can cut it away in sections, and you can slide it around if it need to be re-roofed.
Wow.
Yes, ma'am. But it's nice because when you've got that extra layer there, you're kind of shielding the existing roof from getting any sort of sunshine.
This is a 24 circuit E-monitor that all of these little wires here go to what's called CTs, or current transformers, and they're clipped on to the branch circuit wiring out to every circuit or appliance in the house, okay? They come in here and this analyzes it. There are 24 channels. Right now, power consumption in the building is 1.023 kW, or about 1,000 watts. Let's go through each channel. I know that channel 3 and 4 are the solar panels, and we're putting out 600 watts on one solar panel, and one leg, and then 609. So they typically track. So we're making 1,200 watts and consuming 1,000. So we're putting 200 on the grid right this second.
I guess I'm clear. Are they getting paid? Are they getting credit for that 200 or something on the grid? Monetarily?
Yeah, if they're paying 11 cents a kWh, it'll be a deduction on their bill. If at the end of the month it's a net, what it does is it takes all the positives and all the negatives, and at the end of the month, you either get 11 cents kW for whatever the excess is, or you pay 11 cents for the difference. In other words, if we were consuming 1,500 and putting out 12, they'd be paying for 300 because the solar's offsetting that.
Do they just put that back as a credit on your next month's bill? They don't actually write you a check out?
No, it's just a net.
Okay.
Yeah. So this is that power supply. It also picks up the potential, the 120 volts. So it knows the system's 120 volts. This little thing here is just a power line data access port. So what it's doing is taking the information out of here and putting it on the power lines in here. So when Comcast comes in and gives the family cable,
They just left actually.
okay, we've got another one of these. We'll just plug it into an outlet very close to where cable comes in, take a wire out of this side and plug it into a port on the router, and all this data then will be available on the eMonitor website after we configure the circuits so that we can see a dashboard of what everything in the building's consuming.
What's running right now that's using 1,000 watts?
Don't know.
I mean,
Don't really know.
I don't get the HVAC in. And that's a lot of
I don't
watts.
know.
That is.
Yeah, I don't know.
There ain't any lights on either.
Just a monitor.
No, we've actually got a monitor on it to see how much this uses.
It's the power supply there on the
Plug-in monitor.
Is there a service fee for the monitoring of it or anything like that? Or?
Now, normally, Jeff, who's the integrator, runs on solutions, he would normally charge an integration fee to a normal customer. I don't know how much a month, but he would charge for that, for monitoring. We have, with what we paid for the system and the integration, we've got 1 or 2 years built in to that. But there is a fee. I mean, it's not much, but I mean, there's a fee.
Yeah, we do have an individual monitoring system for the solar as well, and that's saying 1.2, this is saying 1.2, so it's all around. And this is this will be made public on Enphase's website. You can go and actually see every installation in the world through Enphase. You can go click on it, and it'll show a map of where the system is here, and you can look and see what each panel is producing. Like I said earlier.
How does that communicate with? Is it power?
Yeah,
Okay.
it's power line communication.
Okay.
And there is no fee for this either.
Is that something that's needed, or is that something that is optional? If you decide that you just want it to work up there, okay, I'll just.
I don't know.
You don't need it. It's just that if you're going to have this house in a zero energy and solar panels and consumption, to understand how much you're using, you got to have the monitoring.
Well, all we would need would be a very simple device that takes building total and the solar.
Is there a battery backup system for this?
For this house? No. No generators, no battery backup.
Whenever these inverters don't sense line voltage, so if there's a power outage around here, they shut down. It's a VUL.
Is there a way around the safety feature, or is it if your power is out for a week after a hurricane, the solar has no advantage?
Right, those inverters have to sense line voltage before they'll start producing power.
If you couple that with a small generator that would put in, like a propane or some other sort of generator, and gave you some voltage, could it sense that, and then they would switch on and give you the full deal?
We're getting creative.
Yeah, we're getting creative. I mean, I would just
have a tiny generator.
I would
Right
run
now,
generators are a lot less expensive than battery backup PV systems. I'm in the business to sell PV systems. The battery backup systems are very expensive with battery storage.